Welcome to the first lesson in Session 3, Graphing Linear Equations and Inequalities. We start by learning about slope-intercept form of a linear equation. Slope-intercept form is given as y equals mx plus b, where m represents the slope and b represents the y-intercept. It's called slope-intercept form because it's very convenient to identify those two pieces of information. And those two pieces of information will allow us to graph a line. The slope calculates the steepness of a line as a ratio of change in y over the change in x. And the y-intercept is a point with an x value of 0 where the line passes through the y-axis. In the first two examples, we're going to ask you to identify the y-intercept and the slope given the equations. Feel free to push pause, provide the answers, work out the problems as best you can, and then push play to catch up with the explanations. For the first example, 3 represents the coefficient of the linear term, and negative 2 represents the y-intercept. So we express the slope as 3, or 3 over 1 if you wish, and the y-intercept is negative 2, always expressed as a coordinate, 0, negative 2. For the next example, negative 2/5 represents the coefficient of the linear term, which is the slope, negative 2/5, and 3 is the y-intercept, expressed as a coordinate of 0, 3. Next, we're going to ask you to do the same thing given a line. So we're going to ask you to identify the slope and the y-intercept given the line. The y-intercept is easy to start with, so it crosses the y-axis at positive 2. Now we need to find another coordinate. So it looks like the line passes through at exactly this coordinate here, which is 4, negative 1. So how do we get from point A to point B? We count off rise over run. That's how you count off slope. Change in y, which is your vertical change, over the change in x, which is your horizontal change. A nice device for children to use is saying rise over run. So count the rise. In order to get from point A to point B, we go down 3 and we go to the right 4. Down is a negative movement, to the right is a positive movement, giving me a slope of negative 3/4. We already identified our y-intercept at positive 2. So there's our two pieces of information for the first line. Next graph, looks like we have a y-intercept at negative 3. And the next coordinate, I believe, is here at 1, negative 1. So in order to get from point A to point B, we would go up 2 and to the right 1. Both of those are positive movements. Up is positive and to the right is positive. So we have a slope of 2 and a y-intercept at negative 3. Now graphing the equation, starting with the y-intercept, so we have y equals 1/2 x minus 3 equals 0. So we always start with the y-intercept, which would be down here at negative 3, and we count off the slope. So in this case, the slope is 1 over 2, so we would go up 1 and over 2. Up 1, over 2. If we run out of room, we would always go back to the y-intercept and count in the opposite direction. Down 1 and to the left 2. Down 1 and to the left 2. Counting in the opposite direction produces more coordinates, allowing us to get a more complete line. For the next example, y equals negative 3x plus 2, starting with our y-intercept at positive 2, and now I need to count my slope of negative 3. I count down 3 and to the right 1, down 3 and to the right 1. And again, if you run out of room in one direction, go back to your y-intercept and count in the opposite direction. Notice a positive slope moves uphill from left to right, while a negative slope is going to move downhill from left to right. Next, we're going to graph vertical and horizontal lines. So vertical and horizontal lines are always expressed using only a single variable. It's either an equation in terms of x or an equation in terms of y, not both. A horizontal line has a constant y value and is always of the form y equals a, while a vertical line has a constant x value and is always in the form of x equals a. So my first equation, x equals negative 2, that's going to be a vertical line passing through the x-axis at negative 2. While the second example, y equals 3, is going to represent a horizontal line passing through the y-axis at 3. Next, we're going to learn about standard form. Standard form is expressed as ax plus by equals c. where A represents the coefficient of the x term, B represents the coefficient of the y term, and C is our constant. Here's a couple of characteristics about standard form. First, the terms containing x and y are located on the same side of the equation opposite the constant term. So A and B are on the same side opposite of C. Second, A, B, and C all have to be integers. No decimals or fractions are allowed as the coefficients on this standard form equation. And lastly, the leading term, the value of A, has to be positive. So here's a couple of examples of equations provided to you in slope-intercept form, and we're going to manipulate them using sound equation solving strategies to express them in standard form. The first thing we have to do in any case is get x and y on the same side. So for our first equation, we're going to subtract 3x from both sides of the equation, giving me negative 3x plus y equals negative 2. Now all of my coefficients, A, B, and C, are all integers, but the value of A has to be positive. So in order to make that happen, I need to multiply the entire equation by negative 1, giving me 3x minus y equals 2, and I've successfully manipulated that equation from slope-intercept form into standard form. For the equation on the right, y equals negative 3/4 x plus 1, I start by adding 3/4 x to both sides in order to get x and y on the same side of the equation. Next, I need to eliminate the fraction. So I can't have 3/4 as a value for A, so I multiply the entire equation by 4, eliminating the fraction, and transforming my equation into 3x plus 4y equals 4. Standard form is convenient for finding the slope, as well as both x and y intercepts, which all three of those pieces of information are going to be helpful when trying to graph. To find the slope from standard form, I take the opposite of A and divide it by B. In our example, 2x plus 3y equals 9, the value of A is 2, and the value of B is 3. So to find the slope, I just take the opposite of A over B, which is negative 2/3. The x and y intercepts can be identified from standard form by substituting zeros in place of their opposite variable. So for this example, 2x minus 3y equals 6, I'm able to find both the y-intercept and the x-intercept by plugging in zeros for its opposite variable. So to find the y-intercept, I plug in 0 for x, and to find the x-intercept, I plug in 0 for y. So to find the y-intercept, plugging in 0 for x eliminates the term with x and leaves me with negative 3y equals 6, so y is equal to negative 2. So my y-intercept is 0, negative 2. To find the x-intercept, I plug in 0 for y. Eliminating the y term gives me 2x equals 6 and an x value equal to 3. So my x-intercept is at 3, 0. So to graph from standard form, we need to identify two of the three pieces of information that it provides. So standard form, we can identify the slope by taking the opposite of A over B, and we can take the x and the y-intercept by plugging in zeros for opposite variables. If we can identify two of those three pieces of information, then we can produce a line. For my first example, x minus 3y equals negative 1, I'm going to use the slope, and I'm going to use the x-intercept. Notice trying to find the y-intercept is going to produce a fraction, and we want to try not to use fractions as coordinates if we don't have to. So taking the opposite of A over B, I get negative 1 over negative 3, which gives me a slope of 1/3. Plugging in 0 for y to produce the x-intercept gives me an x-intercept at negative 1, 0. So now from my x value of negative 1, my x-intercept, I count a slope of 1/3, up 1 over 3, up 1 over 3, and I have my graph. In example B, I have 4x plus 2y equals 4. In this case, I can identify the x-intercepts and the y-intercepts. So to find the x-intercept, I substitute 0 for y, giving me an x-intercept of 1. And to find my y-intercept, I substitute 0 for x, giving me a y-intercept at 2. So if I have an x-intercept at 1 and a y-intercept at 2, I'll have a line that passes through both of those coordinates. So standard form provides a little bit more flexibility because it produces without very much work, 3 pieces of information. And if we can identify 2 of those pieces of information, then we can graph the line. Finally, we need to graph linear inequalities. When graphing linear inequalities, we have a few extra things to consider in addition to slope and y-intercepts. First, will we be graphing a dashed line or a solid line? We're going to graph with a dashed line when the inequality is written with a less than or greater than. And we're going to graph with a solid line when the inequality is written with less than or equal to or greater than or equal to. Finally, we have to shade. One side of the line or the other is going to contain the solution set. So we need to identify which side of the line contains our solution set. We do this by testing any point on the graph that doesn't lie on the line. If the test point is a solution, then we're going to shade the side of the line that contains the test point. If the test point is not a solution, then we have to shade the opposite side of the line. So we got 2 graphs here. Y is less than negative 2/3 x plus 1. So here we're going to have a dashed line that has a y-intercept at positive 1 and a slope of negative 2/3. So we go down 2 over 3, down 2 and over 3. So there's our slope of negative 2/3, y-intercept of 1. We have a dashed line. There's our graph. Now the easiest point to test is the origin. So I plug in 0, 0 as my test point, and I'm going to identify whether or not it's a solution. Plugging in 0, 0 produces 0 on the left and negative 2/3 times 0 plus 1 on the right, giving me 0 is less than 1. Now 0 is less than 1 is a true statement. What that tells me is that the test point is a solution, which makes every single coordinate on this side of the line solution as well. So I shade the bottom side of that solution. In my other example, 2x minus y is greater than or equal to 3. I identify, this is from standard form, so I'm going to take the y-intercept in this case and the slope. So I take the opposite of a over b, giving me a slope of 2, and I'm going to use a y-intercept of negative 3. This is going to be a solid line because it's a greater than or equal to sign. So I count my y-intercept at 0, negative 3, count off a slope of 2, up 2 over 1, up 2 over 1, up 2 over 1, and I graph a solid line. Now I take the origin as my test point, and I'm going to determine if the origin is a part of my solution set or not. So I plug in 0 for x and 0 for y, which is going to give me 0 is greater than or equal to 3. Now that is a false statement. So since the origin does not satisfy the inequality, we shade the side opposite of the origin. So that wraps up our lesson. Good luck on the quiz, and email us if you have any questions.